Okay, hello everyone. Who here knows what Apache Airflow is? A number of people know. Okay, I'll give a little bit of an explanation, but first, a few words about me. I'm an Apache Airflow PMC member, a member of the Apache Software Foundation because Airflow is part of the Apache family of projects, open source projects, and Apache Software Foundation is one of the biggest foundations in the and oldest open source foundations in the world. I'm also a member of the ASF Security Committee, and if you want to listen about my security related talk about AI and security reports and things that are happening with a very like huge speed right now, I have a talk day after tomorrow as well. Um, Airflow is a data orchestrator, for those who do not know, data orchestrator for any kinds of data pipelines. And very recently, including yesterday, when we released 3.2.0, and I was part of it. So it's also supports AI workflows, all kinds of, and as of a few days, it also supports a native AI support for LLM and all the kinds of things that you can do with AI pipelines. But generally, it's a very diverse data orchestrator and data pipeline orchestrator. Very shortly, you build tasks which are executed in some kind of workflow with some kind of dependencies, conditionally, dynamically, very flexible, on schedule, triggered by external events, and all kinds of things that you expect from a modern orchestrator. And it has a really nice UI that allows you to, and this is the most important part of Airflow. It has a really nice UI that allows you to see your pipelines which are running in production and manage them and rerun in case things are failing, or diagnose them when they are failing, or ask AI to diagnose them for you using the APIs we have at them. So like all these things allow you to have your pipelines defined for like big companies and big deployments, many of them, many data processing tasks, and make them organized and make them manageable from a single place for single UI. Basically, that's what Airflow is. And we had a little bit of a problem 2 years ago when we started Airflow 3 development. Because now Airflow is a third version, and 3.2 was released yesterday, as I mentioned. We had a little bit of problem because we evolved for like more than 10 years now, and we built a kind of massive code base because like we have lots of integrations, hundreds of integrations with different external systems. The system is pretty complex, and it consists of a number of different internal components, and we had it like in one big repository with lots of distributions, lots of Python distributions produced from that repository, uh, and we had to redesign the way how we defined our repository and how we defined the way how we work with it as developers. We have more than 3,700 contributors and like 60, 70 maintainers working on it. So like lots of people working on the same repository. And we've been always thinking like whether we should split into many more smaller projects, or whether we should keep it as a single monorepo. And I've always been just scan it. This is like a detailed description of what I'm talking about. Like I wrote a 4-part blog post describing the whole thing that I'm describing today. So if you want to have more details, you can scan it and look at it. So we've been thinking about like how to work in a way that we can have all those different distributions built and created together, released separately, and working together. This is a problem that many companies, also big companies and big Python deployments, have. How to build cooperating components together with each other, how to work on them together, and how to build them at the same time, and have different versions of different distributions work or different parts of the system work with different other parts of the system in different versions. So the problem we had is like Airflow is releasing even today. Actually, this morning I pushed the release of 90 providers, so called. So we have 90 different Python packages to PyPI. Each of them corresponds to a different integration, external integration that we have, like Google, Amazon, data, fusion, whatever. You can imagine all the kind of integrations we have. And we like, I just pushed hundreds of them, and we do that every 2 weeks. Maybe not all hundreds of them, but we have a lot of those modular kind of small projects inside a single monorepo. And we always done that kind of like, we always build that in using some like, historically we built it using a custom tooling that was kind of extracting parts of the code and producing different kinds of distributions, while we had a single source tree where we worked on everything together. And that was a big problem for us, because it was like, it was completely non-standard. And we went on so the idea was how we can make it more standard, the way how we work, keep the monorepo, because if you've been into this monorepo versus multiple repositories, there are different pros and cons of each, but like monorepo has one big advantage, that you can actually make sure that everything works together very nicely and very easy. So we've been always using monorepo, and we wanted to do a kind of more standard approach. And I went to the, like a few years ago, I went to the like step-by-step implementation of that. The second part of what I'm talking about, like I'll tell about some pains we have, then I'll tell about the standards that we applied to make it works, and then some tooling that we implemented in order to make it easier. So the repository dilemma, whether to have separate repositories or one giant monolith, those have different pros and cons again. The often problem that you see when you like monorepo is generally much better, and like in my opinion, and like Google and Facebook and all the others, all the other big ones that are distributing a lot of different applications that are supposed to work together, they're also working on monorepo. I don't know if you're aware of that, but like Google has like one big giant monorepo of everything. Because you can always test things together, you can always see whether like you can use the latest versions of those repositories, of those different things that other people are working on, without a very costly integration effort. But the giant monolith has its own problems, because like you often import things that you are not supposed to across the versions, across the different distributions. There are some dependencies between different packages which are kind of leaking, and you are not able to make each part of your monorepo independent. So ideally, what you would like to have some kind of combination of that, like have each project independently and self-contained inside your monorepo, but have many of those projects inside this monorepo. That was our goal to achieve. And just to explain the scale of it, so we have like more than a decade old. We have like colossal code base, more than 1 million lines of code. We have 700 plus dependencies that we depend on, which is like introduce massive complexity on resolving them. We release twice monthly up to 100 distributions or like Python packages in PyPI. That many, we have now like a lot of them. We have more than 3,600 contributors, the highest number of contributors in the Apache Software Foundation. And we wanted to get like this frictionless module development, just to show you the scale. And that is like now is very skewed by AI kind of PRs, and you probably have seen that or heard of that. So we're like, this is just last week. We have 217 merge pull requests by 85 authors. Like 159 commits to the main, which is like 160, more than 20 commits a day, more than 20 PRs merged a day. That's a lot. So we have to somehow manage this complexity. You can see me here. Actually, I'm one of the #1 contributor in Airflow with 60 PRs merged during the last week. So like that's a lot. The funny thing, there are 2 bots there. One of them I wrote as well. So like I have a little bit more than that. So we had to manage those custom distributions. We have some circular dependencies between different distributions that we release. And the distributions are like, okay, Airflow core, Task SDK, which is like interface for our Python code that users are writing. And like hundreds of different distributions, the integrations with the external systems. So there were some leaky abstractions inside the Airflow core that like was very difficult to unentangle, um, and and we had to do something about that. We had to eat cake and have it too. So we wanted to build this truly modular application in a single monorepo that we can like work together on the whole of it, but also just focus on one part and only work on that part and whatever it needs, and work it in a standard way. So several years ago, that was difficult because there were no real standards to help us with that. Um, and 3 years ago, I went on a spree to like implement Airflow to be like fully standard, following all the PEPs. And we had the keynote today about the following what Python is doing. We followed what Python packaging team was doing, and we implemented meticulously all the latest standards introduced there in all the toolings like PyProject Toml and all the different kinds of configuration in our build process, so that it can follow absolutely standard tooling of Python. But we still missed one thing, which is the kind of way how we can have all those distributions and all the separate projects inside of our monorepo, how to put them together and work together on all of them at the same time. And luckily, we actually worked with Astral team and UV. And like Astral has been probably everybody knows now. Astral has been acquired by OpenAI, so it's like now OpenAI owned thing. So we've worked actually together with UV, and they built for us a workspace feature. So they built it for Airflow. So we worked together with them, and they modeled it on our needs. So there is a feature called workspace, and I'm just going to show a little bit of how it looks like if you are familiar with the standard Python project structure. So you see you have those are two example distributions inside of our code base, Airflow Core and Airflow CTL. And they have just the standard structure as any other Python project. SRC tests and everything is there. They are all part of the same repository. And even like if you look at this repository of ours, this is like single repository, single Git monorepo we have. You can see that we have many of those. So each of these blue ones on the right side, they are a separate project like this one, like those two that you show on the left side. So it has everything to just, you can go inside the project, build it, and you will build a distribution, and it has separate source tree, separate tests. Everything is isolated inside those. Inside this particular directory. Plus, it has what Workspace gives you actually. If Airflow Core is using another distribution, for example, like Airflow CTL, it can refer to it in its PyProject Toml, and Workspace will automatically use the sources from this particular repository, not install the dependency from the PyPI. So this is the main feature of Workspace. You can just build references and the dependencies between all those different components you have inside your single monorepo, and instead of installing them as dependencies when you work locally, instead of installing them from a PyPI or from other sources, it will just use it directly from your sources. Sounds simple, but it was not like supported or not possible before a workspace feature. So how it works, it's a very simple workflow for developers. Just like this is the main folder of Airflow. Just go UV sync -- refresh if you want to refresh things, and you can see it resolves all packages that all the distributions we have inside our repository, which is like 100 distributions, more than 913 packages in total. And now you have a virtual environment where you can work directly on all those distributions together. So when you change the source code of one of those distributions, you can refer to that source code and use it from the other one, run tests, and it will actually use this changed source without having to reinstalling anything. But also, when you want to only work on one of those distributions, not on the whole of it, you can just go to this directory where the distribution is, run UV sync, and it is like it uninstalls 500 packages because Airflow core doesn't need all of those dependencies. It has a much smaller number of those, and it will this virtual env will only have this particular dependency or this particular distribution, and anything else, anything it depends on and nothing else. And you can switch between those very easily. So you can just go to one distribution, run UV sync, and you will be able to work on this particular part of the code. To another, you work on another part of the code, and the UV makes everything for you so that you are not using things that are not available. So like if you try to import another distribution, another package from your monorepo, which is not your dependency, you will not be able to, because after UV sync, your virtual env will not have this particular project in the Python path. So this is all managed very nicely by UV. We also have a very nice integration with IDEs. So we have some like very easy scripts that just generate setup for your IDE, and whatever you get like in your IntelliJ, you can have all those distributions configured with your sources and tests and everything, and you can see how you can work on that directly in your IDE very easily, or you can select just one of them, and then you can have one project to work. You can work on one project on. So the benefits of having a UV workspace in this case is just like it provides you isolated environments. It has explicit dependencies between different distributions inside the monorepo, and it's very flexible because it can sync parts of the whole project instantly, very, very easily. And the nice thing is also kind of becoming, or I hope it will become, an industry standard. Hatch already supports workspaces modeled after the UV as well. We haven't tried it yet, but like most likely we will be able just to switch to Hatch if we wanted to use the same kind of model. However, there were we had some other things that we had problems with, like who uses pre-commit from people who are here? Who uses prec? Some people use prec. So pre-commit is a nice tool to keep your pre-commit hooks in order. We have more than 170 of those checks to check what before commit or during the commit if everything is fine in your code. And with this scale and this number of projects, like just having in one place is not a good idea. It was not a good idea. So again, we worked with another maintainer who developed Prec, which is kind of one-to-one replacement for pre-commit written in Rust, also very, very fast and with parallelism. And it also is now monorepo aware. So it actually uses the workspace from UV configuration. And you can have several different pre-commit configs in your folders. So you see, again, this is the like two example distributions in our monorepo, and you can see in each of those you have its own pre-commit config, which means that if you just go to the, like in this case, Google integration provider, Google, it will just run only the pre-commits that are relevant to Google. So that actually made us like much more flexible in managing our pre-commit hooks as well, because we could distribute that across the different distributions. However, we had one problem, because in some distributions we wanted to use some shared code, and this is kind of like an innovative part of what we've done. Not really supported yet by any of the tooling, but something that we think it's worth sharing. So we had this need to have some common code like logging and configuration and stuff to be used in different distributions. So like the same code used in different places. And that has a trap, because like you could make it into a shared library, or shared distribution that you use by both. So like Airflow core, Airflow CTL can use Airflow logging, no problem with that. This works fine. However, that introduces a unnecessary coupling, because then if you want to install different versions of those two different distributions, which we should be able to, we want to be able to install different versions, not only the same always in the latest version. Then you sometimes then you'd have to use exactly the same version of the shared library with the same code, which is like kind of introduces the coupling, because if we add some backwards compatible changes in this shared library, that you have to keep the compatibility, that creates all the kinds of complexity. Uh, the problem with Python is that it actually keeps only one version of library. Like you can only use one version of library at the same time in the same virtual environment, as you know. Like different is than npm. In npm, for example, you can have like version 3 of this library, 4, 5, 6, used by different parts of the system, and it will work. Not in Python. So we had to invent something, because we wanted to be able to have one of those distributions use logging in one version and another use logging in different version, but we wanted to develop it in one place. We didn't want to like copy that all over the places. So we, inspired by the Unix concept of shared libraries and Python vendoring, we developed an auto vendoring solution or implementation in our workspace. We use symbolic links without going to a lot of these details, but you use symbolic links to link those different distributions to each other. The shared libraries are just regular standard distributions like any others, like the logging or configuration part. And we do some hatch link magic, some build using those standards of packaging. We just make it works in the way that when you release this package, the shared library is actually vendored in automatically into your distribution that you release. So you have so in different packages, yeah, we have some guard lines. I'll show that to speed up. So for example, in this case, we have a shared configuration library, which we use for different kinds of configuration and use it in different packages or listeners at the bottom. And then this shared configuration library is just, as you see here, symlinked, and then you can see symlinks to the source code in this picture. They are vendored in the packages that we are releasing, but in different packages. So the first one is Airflow SDK package, and Airflow SDK _ shared. And the second is Airflow _ shared. And those are two different libraries that can be installed at the same time in the same environment. So we can install both Airflow core and, in this case, Task SDK distribution at the same time. Each of them will have its own version of the configuration library or logging library that was actually in the sources at exactly the time when we built the package. So like those could be different versions of those libraries at the same time. So I think like so we've a lot of details of that. Like I had to go very, very quickly. So sorry if some of that was not very understandable. And we have like maybe 1-2 minutes for questions. But this blog post I wrote explains a lot more things in detail. So I invite everyone, and if there are any questions, I'm happy to answer them.